Hi, today we will combine the effects of A, H, and K. Here's today's learning target. Given a quadratic function in vertex form, I will be able to describe the effects of A, H, and K. So we've looked at the effects of A, H, and K separately, but today we're going to combine these effects. As a review, let's look at quadratic functions written in vertex form. We have f of x equals a times x minus h quantity squared plus k. Let's look at what each parameter tells us. So h gives us the horizontal translation. It tells us whether to go left or right. And k gives us our vertical translation. It tells us whether to move up or down. And recently, we looked at the parameter a. A gives us our vertical dilation. It tells us whether the graph becomes narrower or wider, so whether there's a stretch or a shrink. Also, if a is negative, there's a reflection of the parabola. The parabola flips around. So with each of these effects in mind, let's take a look at some examples. For our first example, let's describe the transformation of the function f of x equals 2 times x minus 3 quantity squared plus 4. As usual, our first task is to identify A, H, and K. The general form is f of x equals a times x minus h quantity squared plus k. We have an exact match, and here a is replaced by 2, so a equals 2. A equals 2, and 2 is greater than 1, so we'll have a vertical stretch. And then h is replaced by 3. So h equals positive 3, which means we'll be moving to the right. And k is replaced by 4, so k equals positive 4. Since k is positive, we'll be moving up. So now that we identified A, H, and K, we can write our description. So we have a parabola that has a vertical stretch because A is greater than 1. And we also have some translations based on H and K. Since H is positive 3, we know we need to move 3 units to the right. And because k is positive 4, we would also move 4 units up. So I have a parabola, and let's see how the graph changes as we apply each effect. So I have a parabola that has a vertical stretch. Notice how the graph becomes narrower. And then we translate 3 units to the right. Lastly, we move 4 units up, so this is the graph of our given function. Also notice here, the vertex is at h, k, or at the point 3, 4. For our second example, let's describe the transformation of the function f of x equals negative 0.4 times x minus 2 quantity squared minus 7. Let's compare it to the general vertex form. F of x equals a times x minus h quantity squared plus k. Right here, it's a little different, so I'm going to rewrite this function. I'll have f of x equals negative 0.4 times x minus 2 quantity squared plus negative 7. Let's identify a, h, and k. A is replaced by negative 0.4. So let me write it over here. A equals negative 0.4. It's negative, so there will be a reflection. And also, if we just focus on the 0.4, 0.4 is less than 1, so we will have a vertical shrink. The parabola will be wider. Moving on, h is replaced by 2, so h is equal to positive 2. Since it's positive, we will be moving right. And k is replaced by negative 7. So k equals negative 7. We're moving down. So let me write the description. We have a parabola that has, and then we want to think of all the effects. So since a is negative, we have a reflection, so it will be flipped. And since a is less than 1, we will have a vertical shrink. So we'll have a vertical shrink, so a wider parabola. And we also have some translations. So we have horizontal translations and vertical translations. Since h is positive 2, we move 2 units to the right. So 2 units to the right. And also 7 units down because k equals negative 7. So let's look at each effect. We start at our parent function, y equals x squared. And our first effect is the reflection. Notice how the parabola flips over. There is a vertical shrink, so the graph becomes wider, and we translate 2 units to the right and also 7 units downwards. We can easily find the vertex by looking at H and K. Our vertex is the coordinate point 2, -7. For our third example, let's describe the transformation of f of x equals 0.5 times x plus 4 quantity squared plus 1. So I know the vertex form is f of x equals a times x minus h quantity squared plus k. It's not an exact match here, so I have to do some rewriting. F of x equals 0.5 times x minus -4 quantity squared plus 1. A is replaced by 0.5, so I know that A equals 0.5. Since 0.5 is less than 1, I'll have a vertical shrink. And our H is replaced by -4, so H equals -4, which means we'll be moving left. And K is replaced by 1, or +1, so K equals +1, which means we're moving up. So let's write the description. We have a parabola that has, so first of all, a vertical shrink because A is less than 1. So we have a vertical shrink and a translation 4 units to the left because H is negative, and 1 unit up because K is positive. I start with my parent function, and first there's a vertical shrink, so the graph will be wider. Then the parabola translates 4 units to the left, and finally it translates 1 unit up. Again, it's pretty simple to find the vertex based on our function. Since h equals -4 and k equals +1, our vertex is at -4, 1. Please try example 4 on Edpuzzle. Describe the transformation of f of x equals -3 times x plus 2 quantity squared plus 8. Next, let's look at some special cases. So for this example, let's describe the transformation of g of x equals x minus 2 quantity squared plus 3. What might be missing here? I write the general form, which is g of x equals a times x minus h quantity squared plus k. Right here, we actually have an invisible 1. So in this case, a is replaced by this invisible 1. So a just equals 1. There's no vertical dilation. And then our h is replaced by 2. So h equals positive 2. We'll be moving to the right. And k is replaced by 3. So k equals positive 3. We'll be moving up. So in this case, there's translations, but there are no dilations. So we have a parabola that has no dilation because a is equal to 1, not greater than or less than. And we also have the translations based on h and k. So in which direction is the parabola going to move? We will move 2 units to the right because h equals positive 2. And also 3 units up because k equals positive 3. We have a parabola that has no dilation and has a translation 2 units to the right and 3 units up. So let's look at the graph for this. We start at y equals x squared, and since there is no dilation, we move on to the translations. We translate 2 units to the right. And then we translate 3 units upwards. Our vertex is at the coordinate point 2, 3. So for this example, we had no vertical dilation because a equals 1. Let's look at another special case. Describe the transformation of j of x equals 3x squared plus 5. What's missing here? Our usual general form is j of x equals a times x minus h quantity squared plus k. Here we're missing our h parameter. We're missing this whole part. So let's rewrite this a little so it's easier to see. J of x equals 3 times x minus 0 quantity squared plus 5. And I'm using 0 right here to symbolize the emptiness. A is replaced by 3, so I know that a equals 3. And since this 3 is greater than 1, I'll have a vertical stretch. The parabola will be narrower. Next, since there was no h value, I know that h equals 0. Since h equals 0, there's no horizontal translation. We don't go left or right. And then k is replaced by 5. K equals positive 5, so we would move up. Alright, so let's write the description down. We have a parabola that has a... So first of all, we have a vertical stretch because a which was 3, is greater than 1. And we have a translation. Well, we don't have a horizontal translation since h equals 0, but we do have a vertical translation. We move 5 units up because k is positive. Starting from our parent function graph, so the graph of y equals x squared, the graph becomes narrower since a is greater than 1, so there's a vertical stretch. And then we don't move left or right, but we do move 5 units up. In this case, our vertex is at the point 0, 5. Let's look at one more special case together. So let's describe the transformation of the function m of x equals 0.3 times x minus 2 quantity squared. What parameter is missing here? So when I write out the general form, m of x equals a times x minus h quantity squared plus k, I'm missing the k parameter. But I can just use 0 to symbolize this emptiness. So now I can identify a, h, and k. So for a, I know it equals 0.3, and 0.3 is less than 1, which means I have a vertical shrink. And then h is replaced by 2, so h equals positive 2, so I'll be moving to the right. And then for k, since k equals 0, I will not be moving up or down. There's no vertical translation. So let's write the description. A parabola that has, so what are the effects? I know there's a vertical shrink, so the graph will look wider. And then there's no vertical translation, but we still have a horizontal translation. Since we have h equals positive 2, we move 2 units to the right. So if we started from the graph y equals x squared, the graph becomes wider because there is a vertical shrink, and then we move 2 units to the right. And that's it, because there is no vertical translation. Here, my vertex is at the coordinate point 2, 0. So for this special case, there was no k value, so there was no vertical translation. As a review, the vertex form of a quadratic function is f of x equals a times x minus h quantity squared plus k. And for the past few lessons, we've been looking at the effects of a, h, and k. A gives you the dilation. It tells you whether there is a vertical stretch or a vertical shrink. Also, if a is negative, there is a reflection. H gives you the horizontal translation. That is, H tells you to move left or right. And K gives you the vertical translation. That is, K tells you to move up or down. Great job on this series, and please remember to turn in your notes.